Hey everyone, I'm very happy to be here at the CodeSpace DevOps Stage Conference. It's a shame that I couldn't attend in person and this conference had to become virtual, but I hope everyone's doing well and I thank everyone for tuning in. And so today I will talk a little bit about the Harbor project, which is a graduated project in CNCF, the Cloud Native Computing Foundation, and it's a registry for managing your container images and other artifacts. So this is meant to be an introductory session, um, fairly light, give you a high-level overview of what the Harbor Registry is, the current state of the project, why you might need it, and focus on some of the features that we've worked on in the last couple of releases. So quick introduction, I'm Alex Xu. I'm a product manager in the Cloud Native team at VMware, leading the Harbor effort. So I'm responsible for trying to understand the requirements around the container registry, collecting valuable feedback from the community, making sure that we're always improving and seeing sustained growth within the community. So what is Harbor? Well, Harbor is a cloud native registry that can store, sign, and scan content. And so if you think about what a registry is, it's really just a place to host and manage your artifacts. And so when we started this project back in 2014, we set to build an on-prem registry, leveraging the Docker distribution, which was the de facto standard at the time on storing Docker images. But we also wanted to address some of the issues that we come across ourselves while using Docker Hub. And then over time, we've added more services and features to it, like lifecycle management, security features like signing and scanning. And so that's basically how the project came about. And so our mission is to be the best cloud native registry for Kubernetes. And so we started with support for Docker images, and then we expanded to Helm charts. And now with OCI, which I'll talk about in detail later, which is the whole theme of Harbor 2.0, we can support any OCI compatible artifacts. So let's start with a quick timeline of the project. The biggest announcement this time around is that we've officially reached graduated status in CNCF. And so we become the 11th project in CNCF to do so, along with projects like Kubernetes, Containerd, Helm, Prometheus, Envoy, Core DNS. But you can see we started this journey back in 2014. It was actually founded as an internal project in China R&D, VMware. And we opened it up to other teams in VMware and it got good feedback. And eventually we donated to OpenCN or CNCF as an open source project. Just over the course of, a little over 4 years, we became a sandbox project, went into incubation, and then we recently graduated in June of this year. And so the project reaching that graduate stage shows that it has reached a certain level of maturity, but it's really the potential and the roadmap for the project that sort of drives this decision. And so we're still striving for more community contribution and looking forward to working with everyone. So this is a quick overview of the various pieces, core capabilities that make up Harbor. And so we'll go over a couple of these real quick. The first thing is access control. So you can use local DB, you can use LDAP or OIDC to connect to Harbor and to manage your users and their permissions in Harbor projects. If you've never used Harbor, you don't know what Harbor projects are, and think of projects as our concept of a namespace. So it has its own set of repositories and images, and that's completely isolated from each other. So it's our highest level of tenancy. There are also robot accounts that are for service account scenarios, CI/CD type of scenarios to automate the pushing and pulling of your images. You can also configure push or pull-based replication to and from other third-party registries. So you can configure replication policy to something like Docker Hub or another Harbor instance, but it can also be to a third-party solution like Artifactory or Quay, which are other registry solutions on the market, and the other popular public cloud registries like GCR, ACR, ACR. We also support some of the popular ones here in China, like um, Alibaba Cloud's registry and Huawei Cloud Registry. So Harbor also has the ability to scan images from within the Harbor UI, leveraging popular image scanning solutions like Trivi, CSP, Encore, Sysdig, or Claire. And then once you have the scanning results with the list of discovered vulnerabilities, you can actually create policies around these, security policies based on these results. So you can create a policy like disallow image pulling if there's any CV found of a certain severity or higher. You can also sign images leveraging Docker Content Trust, which is built into Harbor. And likewise, you can create image pulling policies based on the signature. So for example, you can prevent unsigned images from being deployed into your environment. As you can see here, we support managing Helm charts. Previously, this was done through a third-party extension called Trivi. But then with 2.0, you can now push these directly to your registry. So they sit alongside your container images, and they don't have to be managed separately from your images. So there are actually two places you can access your charts within Harbor right now. There's a single web console for managing your users, your artifacts, your policies, running scheduled tasks like garbage collection, retention policies. And then everything that you can do on UI, you can do through our API to allow some degree of automation around all the tasks. And finally, Harbor can be deployed in either Docker Compose format or using Helm chart as a Kubernetes cluster. We also have an operator version of Harbor that will be releasing very soon. So you can deploy it as a Kubernetes cluster with full high availability. And that's across all the different components within Harbor, like across your database, your Redis cache, your persistent storage, everything. And so this is an overview of the latest Harbor 2.0 and its architecture makeup. You can see that we're still built around the Docker distribution. And just going from the top, up here is the list of clients that you can use to interact with Harbor through Docker CLI, through kubelet. We support Helm v3. And since Harbor 2.0 sees support for a lot of additional cloud-native artifact types, there are all these other clients that the different artifact authors have built for pushing their artifacts to an OCI registry. So for example, Aura's listed here is a very popular client that has since been donated to OCI, but it can be used for pushing a lot of generic OCI artifacts. Like you can push OCI indexes, you can push Helm charts, you can push open policy agents, singularity files. So you can see here that Chart Museum is still a component within Harbor. So like I mentioned, there are actually two places to potentially host your charts. You can host them in Chart Museum as well as in the OCI compliant Docker registry. But we do have plans to deprecate Chart Museum in the future. And then on the right-hand side, we have the list of supported scanners. Scanners are added in out-of-tree fashion through our pluggable interrogation services framework. I'll talk about what that is in a second, but it's essentially a way for you to pair any third-party scanner that you've either purchased or you've downloaded and have deployed already. You can pair that against your Harbor, and you can run multiple scanners against the same set of projects within Harbor. And then at the bottom, we've listed, or we've expanded the list of replication targets. So you can replicate to not just another Harbor instance or to something like Docker Hub, but a lot of the SaaS registries as well. You can replicate other artifacts beyond just images and Helm charts. But obviously that depends on the supportability of these artifacts on the target registry as well. So I want to talk a little bit about Harbor 2.0. Harbor 2.0 was all about becoming an OCI compliant registry. you might have heard the terms OCI compliant or OCI conformant, OCI capable. So we should talk about what OCI is before we talk about what it means for Harbor to be an OCI compliant registry. So we start with this picture, and we start with Docker, or more precisely, the Docker distribution on the left-hand side. And the Docker distribution, or the Docker registry, started out as just essentially a content store for storing Docker images. And so Harbor as a registry, being that it's built around Docker distribution, is just some HTTP API backed by that content store. And so up until very recently, the only thing that out of all the artifacts shown on the right-hand side that you can actually push on the Harbor and manage through Harbor was container images. Yes, you can push Helm charts like we talked about earlier, but they were stored separately in the third-party repository called Chart Museum. And that meant the charts had to be managed in its own way, separately from the images, and didn't get a lot of the same features, the same feature set as container images had, like tag retention and tag immutability. You also can't scan Helm charts. But that's more of a limitation of the scanner vendors themselves. And so OCI, or Open Container Initiative, is a group that came along to define specifications around image format, runtime, and distribution for a broader set of cloud native artifacts. So, different artifacts of various sizes and formats can all be supported through something like Docker Registry, right? The goal was to, it wanted the Docker distribution to be able to deliver a registry that is secure, it's layered, it's cross-referenceable. So it took the Docker v2.2 image spec as a starting point, and it came up with its own specifications around image format and image runtime. And so what this picture is attempting to capture is a little piece of that history, or the process, which is OCI formalizing these specs, and then that work was immersed back into the Docker distribution so that they can fully support OCI images. And so Docker distribution, and in turn Harbor, can now support hosting these new cloud native artifacts that we've heard so much about, like Helm charts. So if you don't know what these are, listed on the right hand side, this is a Docker image, a Helm chart. The third one is a CNAB. It's called a Cloud Native Application Bundle, which is another artifact type for application deployments, or deployment files representing applications built by the guys over at Microsoft. Open Policy Agent, Singularity. So now all of these can be pushed onto Harbor and curated through Harbor. And so being able to host Docker manifest list is one of the things that came out of this support for OCI. And a Docker manifest list is basically something that has existed for a while, but was previously unsupported by Harbor. And in fairness, it was unsupported by most registries. It's actually surprising how few support it. But a manifest list is essentially, think of it as a packaging of manifests. If you look at this picture, you can see the manifest itself at the left-hand side. On the top left is a SHA in and of itself, and it's acting as a pointer to all these other images, each built for a specific architecture. And so it's holding these together in some way. And this structure is what allows you to use the same name for images that are built for different hardware with different architectures. So just try to keep this in the back of your head, that there is this index structure called a manifest list, and it's very crucial. So Docker Hub is actually a really good example of something that is OCI compliant. And maybe it's the first one that's fully OCI compliant. And so it can fully handle the manifest list that we just talked about. As a matter of fact, pretty much all the official images that you are seeing on Docker Hub today are some form of a manifest list, or it's using a manifest list, allowing for different platforms to be supported using that same image name, colon image tag combination, right? So shown here is the BusyBox image with tag latest. And you can see that it's actually referencing multiple SHA digests for different architectures. You have Linux, you have ARM, you have MIPS, and you even have different variants of these architectures. And so when you go on Docker Hub today and you do a Docker pull busybox, it will actually fetch the version of that image that matches your client. So unless you're specifically pulling by digest, if you pull by tag, Docker Hub will responsibly fetch the correct version of that image for you. And so that's the experience that we wanted to deliver with Harbor, that users can push manifest lists, that they can manage these lists as a whole, as a whole entity, but also manage the images within individually. So that's one use of an OSI index, this multi-architecture or multi-arch image that is very common on Docker Hub. But there are other artifacts that are leveraging this structure, some of which are shown here. So here we're looking at a project within Harbor. We're actually looking at a specific repository within that project. And you can see that it contains a container image, a Helm chart, a CNAB, Cloud Native Application Bundle, and another Docker image, all hosted in the same project. And they're distinguished by their label. And so I put this here to really draw contrast with the 1.x version of Harbor. If anyone's ever used the previous 1.x version, you know that you can only have container images in projects. You can't have any of the other more exotic artifacts. It's also, arranged differently. But now you can have all these managed at the same time. So this screenshot is actually in reference to one of the biggest issues that this support for OCI allowed us to solve, which is being able to delete a tag without deleting the manifest digest itself. Previously, when you delete a tag, you're going to be deleting all the other tags that's shared on that digest, as well as the underlying digest itself. So it seems like a trivial enough problem to solve, but it's actually very difficult, and it's been a constant pain for us. Lots of users, lots of companies that build services on top of Harbor have complained about this, and now this is doable in 2.0. And so here we have for a particular image digest, you can see there are two tags or list of tags for that digest, and you can now individually add or delete a portion of these tags. And so that's the issue that we had for a long time, the inability to freely manipulate tags without triggering deleting a digest. And yeah, it was due to a limitation in the distribution, the Docker distribution upstream, and the work that we did to make it OCI compliant registry. The solution was really a byproduct of that work, because we essentially had to introduce another layer. We introduced the idea of a Harbor tag, which is cushioning those calls to the Docker registry APIs. So whenever a user clicks on add tag or remove tag, he's actually operating on the cosmetic layer instead of directly interacting with the registry. So if you're one of the users who had reached out to us about this problem and created a feature request for it, you can finally now delete a tag without deleting the image. Also, 2.0, for 2.0, there was a huge validation effort for all the existing feature sets of Harbor, for all the new artifacts that we can now support, that can be onboarded. And this goes back to the point I made earlier about OCI index. And a lot of this boils down to, we want to be able to both manage the index as a whole structure, as well as manage the reference images within individually. And it's always a trade-off between flexibility versus security and isolation, right? And it's tricky because you can create an index several times over. You can wrap an index within an index. You can cross-reference another digest in a different bundle. And so it really adds some complexity and changes the calculus of how users choose to store and manage their artifacts. And so that means everything that we have provided, from simple actions like pushing, pulling, tagging, deleting artifacts to things that are policy driven, like tag retention, replication, immutability, security deployment policies. Everything had to be reworked and reconstituted in some form. And we had mentioned, the CNAB before. The CNAB is actually a very good example of a very opinionated usage of a manifest list or the OSI index. It's leveraging the index, but it's almost exploiting the latitude in that specification. And it's using it to create something that's not totally in line with the original goal of the spec, which is for multi-arch support, whereas the CNAB is treating the bundle as an application. And so it's packaging all the different pieces of the application. So if for example, it's more of an app, right? So you could have your web server, your load balancer, your cache, all of that wrapped within your bundle. And so this just goes to show that different vendors have different implementations, and it's an important step that allows Harbor to attract different artifact authors. So that's probably the biggest piece for this release. Now the other work that we did for the version 2.0 release was replacing Claire image scanner with Trivi, which is another image scanner by Aqua Security as our default image scanner. And Claire has been our default scanner for probably since the first version of Harbor. And we started looking at other scanners because users have been coming to us and asking, I'm using such and such scanner, or I've already paid for another scanner. Can I somehow use that? Can I somehow pair that against Harbor? And, we had talked about the work we did to open up those partnerships with other scanners through our integration services framework. But this is just taking a step further with regard to the embedded default image scanner. And so very simply, we landed on Trivi because it's simple, it's comprehensive, it's fast, and it's accurate. It's also easier to set up. There's no need to manage DB instance separately. It runs in Dockerless mode. And Trivi has wider coverage for scanning different operating systems and application dependency managers. A lot of which are listed here, but there are more. This is by no means a comprehensive list. We found Trivi to just be all around superior in conducting deeper scans and capturing more CVs across Debian, across Ubuntu, SUSE, Photon OS. And so, we're very happy that we made this choice. So this is a screenshot of what it looks like in the Harbor UI right now. And so this is showing how these scanners are actually configured in Harbor UI. So notice that we have configured both Trivi and Claire, the two scanners, and there is a system default. The system default is the one that all projects will get after getting created. And also notice that this is under administration, so the configuration is only exposed to the system admin and not the project admin. The project admin within the project configuration page can pick from this list of configure scanners to use for that particular project. And he can switch between the scanners and compare the scanner results. So you can scan the same report with Trivi, and then you can scan it with Claire again and get two sets of vulnerability reports. Right, the value of the different scanners is that they're all connecting to their own curated databases, so they have different, interpretation of what constitutes a vulnerability. They have their own interpretation of how severe that vulnerability is, so they have assigned different scores to them, and they have their own remediation procedures. And so we want to open up that ecosystem and allow users to use whatever scanner that they want with Harbor and not, force them to use just Trivi or just Claire. And so, we started supporting quite a few. there's more. We actually started supporting Cystic Image Scanner, Cystic Secure in the Harbor 2.1, and we're also looking at using the same interrogation services framework to onboard other license checkers and compliance checkers beyond just image scanners, and maybe scanning for dependencies, scanning for the bill of materials. So it's an out-of-tree framework that allows us to work with more partners and open up that ecosystem to more vendors in the future. So unfortunately, you still can't scan all the artifacts that we can now host, but you can, for example, you can't scan Helm charts and you can't scan OPAs, I don't think. But that's not really a limitation of Harbor, and that's just a limitation of the scanner vendors themselves. So it's that's really work on the scanner vendors to add support for this, but we're enabling them to do so by opening up the platform to everyone to foster competition. So that's Harbor 2.0 in a nutshell. We actually just released a Harbor 2.1 last week, which was also a really big release. And so I'm going to go over a couple of features that we worked on in that release as well. So the first one we'll talk about is called Proxy Cache. Proxy Cache is the ability for Harbor to act as a pull-through cache for another remote registry. And we can call that remote registry the target or the remote or the upstream. And so this is really useful in situations where you have Docker nodes that have limited connectivity or no connectivity to that target instance. And so think of it as, you have some central registry where all the changes within your team or within your company, your organization is happening, but you need these changes to be synced down to the rest of your clients. But it can be very difficult to access, right? And that could be due to a number of reasons. It could be it could be by design for security or compliance, or pure connectivity issues, limited egress options. If you saw the recent announcement from Docker Hub, there's a new Docker Hub rate limiting policy that goes into effect November 1st of this year, which is they will be limiting the number of both authenticated calls as well as anonymous calls for free users. I believe it's something like 200 per 6 hours, something to that effect. And so, people have been coming to us and asking us for this capability to get around, being throttled by Docker Hub or being IP banned by Docker Hub because you're pulling too fast or you're pulling too much, right? There's frequency and volume both factor into how Docker Hub handled, when they think you're pulling too much. And so, yeah, Docker Hub is one of the use cases that we had in mind when we worked on this feature, because it's something that clients from all over the world are connecting to and attempting to pull from. And so what this feature is it's called Harbor Proxy Cache, and it's meant to address this very problem. So you're basically deploying Harbor and letting Harbor serve as an intermediary, as a middleman to connect those clients and the upstream registry they're trying to hit. So Harbor will pull the images from that remote target registry for you. It'll cache it in its cache and then serve it to the clients. So imagine 100 clients trying to pull from Docker Hub. Well, if they have, if they can use that shared Harbor instance somehow, then Harbor can pull once from Docker Hub and then serve it to that 100 clients. And it's much faster. It minimizes traversal over the network, and it prevents you from getting IP banned. And this is a screenshot of the workflow. And if you've ever used Harbor, you start any workflow by creating a project. and adding your users to it. Well, a proxy project is basically just like a regular project, except there's an option at the very bottom, if you look at the screenshot, to configure it as a proxy cache. And when you do that, you have to enter in the endpoint that you're proxying for. So you have to put in the endpoint of that target registry, as well as the credentials of your user account. And once you do that, anytime you pull from that Harbor project, it'll actually go out to the project that it's proxying for to download the image and then serve it to you via its cache. So instead of, you have to modify your Docker pull command and your pod specs, YAMLs to pull from the Harbor proxy project instead of the Docker Hub one, or whatever that target is. It could proxy for another Harbor instance. It could proxy for right now we support Docker Hub, we support Harbor in any Docker distribution based, but we are adding more to that list. So you can potentially proxy for something like GZR, proxy for ACR, proxy for Quay, perhaps. And so that's the basic idea. And every time you pull from the proxy cache, it will compare the image in its cache with the image in the upstream by looking at the digest. So it'll always give the freshest copy or the most updated copy to the client. So if it finds that the copy in its cache is stale, it'll go out to the proxy to re-pull the image, get the newest version, cache it, and then serve it to the clients. So it's really helpful capability, especially in light of the new Docker Hub rate limiting announcement. So the second feature I want to talk about is called non-blocking garbage collection. This is also part of the 2.1 payload. So for the current garbage collection capability in Harbor, although it doesn't lock out the registry and it keeps it online, which means that you can still interact with the Harbor registry. You can still view your artifacts. You can still run your policies, but there are things that you cannot do right now when you're running GC. Like you can't push to it, and you can't delete images because there's it basically goes into read-only mode. And so the non-blocking GC gets rid of that mechanism that puts it into read-only, so you can do anything you want. Basically, it runs completely silent in the background with no impact to any registry operations like pushing, pulling, deletions. Imagine if you're deleting an image. Imagine you have an image that's marked for deletion because of GC, and you're pushing that same image. Well, the registry will actually resolve the layers of that image that should be kept and the ones that should be deleted. So there's no risk of image corruption. It's also runs much faster than it previously did because we reworked the entire backend. Also partly because of the work that we did for the OCI support. So that's the second feature called non-blocking garbage collection. The third one I want to talk about is called P2P integration. So with P2P, it's really a way to leverage existing P2P vendors like Alibaba Dragonfly and Uber Kraken, which are both CNCF projects, for better image geo-distribution to thousands or tens of thousands of nodes, which is something that is not really tested on Harbor. We want to leverage their superior P2P distribution mechanisms to do this, essentially. So we went the same route of opening up that ecosystem to different P2P vendors and allow them to be paired against Harbor. But what this means within Harbor is that there is an action called preheating. And what preheating is basically migrating the images across to the P2P vendor side, where it's prepped for P2P distribution. the data is basically, the content is seeded through a series of nodes that is run in a highly scalable and highly available fashion on the P2P side. And Kraken has its own way of doing this, and Dragonfly has its own way of doing this. So it's very vendor specific, and we're sort of handing that work or that responsibility to the P2P provider. Very similar to what we did with the interrogation services framework, and allowing Harbor to be paired with different image scanners, so everyone can use the scanner or the P2P solution that they like or that they've already deployed and invested into. And the preheating happens in a very controlled and very secured way through a series of policies. So if you think about preheating, because it's moving the image from Harbor to another environment, right? It's very similar to how you think about pulling the image from Harbor. It signifies the deployment of that image into the wild. And so there needs to be security policies around how and when that image can be preheated. So we can define policies such as only signed images can be preheated, or only scanned images with known vulnerability of a certain criticality or lower can be preheated, or please preheat on push, or some combination of these conditions. And also specifying a certain set of tags and labels on which to enact these policies, like you would with tag retention and tag immutability. So I talked about some of the things that we worked on in 2.0 and 2.1. Just briefly on the roadmap, we talked about the P2P, the proxy cache, interrogation services, and webhooks were sort of released in previous versions, 1.9 and 1.10. We're really focused on two things right now. One is the operator, which is deploying Harbor through a Harbor operator as a Kubernetes cluster, and that's fully highly available. And the other thing is allowing the images that are signed to be replicated to a different environment without losing that signature, which is, it's not feasible right now because of a limitation of Docker Content Trust, or rather it's a limitation of Notary. But for the upcoming Notary v2, it's really geared towards the multi-registry world. So you can replicate a signed image from one registry to another without invalidating that signature. So your image is secured from, as you sync it across to a different environment. Observability is referring to bringing Prometheus integration, Prometheus support for Harbor, so you can monitor, key registry operations, as well as the orchestration itself, the Kubernetes cluster that it's running in, and the node or platform information like CPU, RAM, disk, everything, and exposing that as an endpoint to Prometheus. So that's all coming in Harbor 2.2, which is slated for end of year. Just a quick word on the community. The community is doing really well. We appreciate everyone's support, whether it's raising a request or finding a bug on GitHub, submitting PRs, helping us do some code reviews, or just attending meetings like this one, right? Which I really appreciate, giving me the chance to come here and talk about Harbor. We're at 12.8K stars actually on GitHub, and more than 200 contributors. And you can see that a lot of companies have been using Harbor for a long time, and they have some strategic partnerships with us, lots of service providers and commercial products built on top of Harbor. So the community is doing really strong. We also have the bi-weekly community meetings that are held, bi-weekly. We actually have two sessions on the same day. One that's Asia time zone friendly at 9:30 p.m. APJ time, and then another one right after at 4:30 a.m. APJ time. So for the audience in Ukraine, maybe the second one is probably a better fit. But we talk about the two sessions are pretty much we talked about the same material. It's just two different hosters. And so that's when you can share your experience with Harbor, ask questions. We also have some feature demos, and we talked about the latest updates on Harbor. So and all the meetings are, I just want to mention, all the meetings are recorded on YouTube. You can go to that link in the slide, and it has the link to the YouTube for previous recordings. You can look at previous slides, and it walks you through how to interact with us on Slack, on GitHub, by email, whatever you want. So that's all I have prepared for today. Thanks for inviting me to come here and talk about Harbor, and we appreciate any feedback that you may have. We just released the 2.1, so please go ahead and try it out. Thanks, guys.